As I said earlier, our topic today is calculation on machines, and then the objectives for today's lesson is 1. We are going to understand the concept of machines here. We will start with the definition, then we mention a few examples of machines, then we also state the uses of machines. Before we try to explain the terms used in machines, we need to understand the terms before we can take calculations on machines. Then we state the velocity ratio for different machines, and then we proceed to taking more questions. So let's start. So what are machines? So machines are just devices that helps to make work easy. So what we are just saying in the sense is just that we want to overcome a very big load with just a small effort, then we think machines. And examples of machine in our houses, we have lots of them, from our blender to the washing machine. In the industry, we have pliers, we have wheelbarrows, we have pulleys, we have levers, and we have a whole lot of them. And they are very useful to us because, 1, it makes our work easy and faster. It makes our work efficient. It also makes our work very perfect. And then machines are very versatile. And then in no time, machines help us to get our work done. And on the screen, you can see the different types of machines we have. You can see the lever there with the fulcrum, the load, and the efforts. And then you can see the pulley there. The pulleys are used to lifting and then bringing down heavy loads. Then you can see the wheel and axle, the one we use in our fetcher to draw heavy loads from a well. Then you can see the inclined plane, wedge, and screw. So all these are examples of machines. So as we continue, you are going to understand more the concept of machines, and you are going to understand calculations involving machines. So let's start with the definitions of terms used in machines. So we basically have 3 terms used in describing the machine. We have the mechanical advantage, which I'm going to short as MA. We also have the velocity ratio, and we have the efficiency. So let's start with the mechanical advantage. So the mechanical advantage, also referred to as the force ratio, is defined as the ratio of the load to the effort. So the mechanical advantage is defined as the ratio of the load to the effort, and it is also defined as the ratio of the output force to the input force. And that's how they got this name, force ratio. So at times in why questions, you might be like, they might want to play a trick on students and say that calculate the force ratios. So just know that the mechanical advantage and force ratio are the same thing, and they can be used interchangeably. So the velocity ratio, on the other hand, is the ratio of the distance moved by effort to the distance moved by load. To the distance moved by load. So unlike the MA, that is load over effort, both of them are they are dimensionless. And when we say a parameter or a quantity is dimensionless in physics, what we mean is that they have no units. So you can see from here that the load is measured in Newton. The effort is also measured in Newton. So when they divide, they cancel out. So that tells us that they have no units. So the mechanical advantage of machines can just be stated as has 5, 4, 3, unlike other quantities that have units. All they just have is magnitude. And the efficiency, on the other hand, can be defined as as mechanical advantage over velocity ratio times times 100. So a quick run starting from MA, we define the mechanical advantage as load over effort. Then we define the velocity ratio as the distance moved by effort over distance moved by load. And then we define the efficiency as mechanical advantage over velocity ratio times 100. So I've seen lots of questions whereby students will be told to prove this, that how do we come across this. So let's just quickly do that here. Let's do that on this place. So when you are asked questions like that, you can easily just prove it. So what we do is we start from efficiency is defined as work output over work input times 100. Yeah, so we start from there, that efficiency is equal to work output over work input times 100. Then we know that our work is equal to what? Force times what? Times distance. So when we talk with respect to work output, we are talking with respect to what? To load. So the work output will be the product of the load times the what? Distance moved by load, and then the work input will be the product of the effort times the distance moved by effort. So when you think work output, what you think is what? Is load, and when you think work input, what you think is what? Is effort. So this applies to load, and this one here applies to what? To effort. So that we can have our formula to look something like this. That efficiency is equal to load times distance moved by load all divided by effort times distance moved by effort. And since the efficiency is represented in percentage, all we just have to do is multiply them with what? With 100. So a first one, all I want to do now is to split this one. We all know that when we have something like 1 times 2 over 2 times 3, this expression can be written as 1 over 2 times 2 over 3. So that's what I want to do here. I want to separate this so that I have something like efficiency is equal to load over effort times, you can see what I did there, I separated it, times distance moved by load over distance moved by effort. Then don't forget to put times 100 there. Yeah, so all I did was to separate it. Then from here we can say that efficiency is equal, or let's make this move. We can say that 1 over velocity ratio is equal to distance moved by effort over distance moved by load. I'm sure you are wondering how I got to this step. I'm going to explain it now. Okay, so see what I did here. From here, we said that velocity ratio is equal to distance moved by effort over distance moved by load, right? Okay, so if we take the reciprocal of this now, that is 1 over velocity ratio, that means we are going to what? Swap this one back. So don't forget our law in maths that whatever we do to the left-hand side, we also have to do the same thing to the right-hand side, right? So if I take the reciprocal of velocity ratio, I also have to take the reciprocal of the right-hand side. So that is what gave birth to this now. So that I have 1 over velocity ratio is equal to distance moved by effort over distance moved by load. Sorry, this has to be load because we need to like swap it back. We need to swap it back, you can see. Reciprocal of this one also went up. So I can now say finally now that my what? That my efficiency is equal to load over effort times the whole of this now is my velocity rate is 1 over VR now. So I'm going to write it as 1 VR times what? Times 100. It's very simple. I know it looks kind of, but it's very simple. Just take it step after step. And finally now, we can now say that efficiency is equal to, don't forget our load over effort is MA. So we say it's MA over VR times 100. Proved. Yeah, so let me just quickly run through it again for those of you that didn't get me the first time. So we started with efficiency is equal to work output over work input times 100. Then we also said that our work is equal to what? Force times distance. And I said that whenever we hear the word work input, load comes to our mind, and when we hear the word work input, effort comes to our mind. So that we can now express our efficiency as load times distance moved by load divided by effort times distance moved by effort times 100. So all I did is to split it at this point here now, so that I have load over effort times distance moved by load over distance moved by effort. So all I did now is to what? Is to take the reciprocal of this now. Distance moved by load over distance moved by effort is equal to what? 1 over velocity ratio. Since velocity ratio is equal to distance moved by effort over distance moved by load. And from there, everything becomes solved, because don't forget our load over effort still remains mechanical advantage, and this gives birth to this. So the only tricky part there is just once you get here, just take the reciprocal of this guy here, and then you are going to get to this place. So let's move on. Let's lay our hands on some questions to understand everything we've talked so far. So this first question is asking us that what do you understand by the statement that the force ratio of a machine is 5 and its velocity ratio is 8? So this question is just the same thing as an exam body telling you to define mechanical advantage and velocity ratio. But most times they feel questions like this are too direct, and then they try to like come in an indirect way to ask you the same question but in a different way now. So that question is just the same as them telling you to define mechanical advantage. So all you just have to say is just that the meaning of the statement that the force ratio of a machine is 5 means that the ratio of the load to its effort is equal to what? 5. As simple as that. Or you can just say that the load is 5 times the effort applied. See, very simple. It's still the same thing, still the same question, but in a different way. So the statement, the force ratio of a machine is 5, means that the ratio of the load to the effort is equal to 5, and then the velocity ratio is 8, means that the ratio of the distance moved by the effort to the distance moved by the load is what? Is 8. Or we can say it that the distance moved by the effort is 8 times the distance moved by the load. As simple as that. So the second question here is saying that a machine whose efficiency is 75% is used to lift a load of 1000 Newton. Calculate the effort put into the machine if it has a velocity ratio of 4. So a very simple question. So let's see how the solution is going to be. But before then, I want to write down a list of the formulas we've derived today, or we've talked about today, starting with the mechanical advantage. So I said our MA, which is mechanical advantage, is equals to load over effort. We also said our velocity ratio is distance moved by effort over distance moved by load. Okay? And then we also said that our efficiency is MA over velocity ratio times 100. Yeah. So those are the three main formulas we've talked about today. So you can just jot them down so you won't forget. You won't forget. So let's move on to this question now. So we are told that the machine whose efficiency is 75%. So it has an efficiency of 75%, and it's used to lift a load of 1000 Newton. Okay, used to lift a load of 1000 Newton. Calculate the effort. So the question wants us to calculate the effort applied. So the effort is unknown. If it has a velocity ratio of 4. Yeah. So before we can get that effort, the first thing we need to do is what? We need to calculate the mechanical advantage. Don't forget that the mechanical advantage. This formula is the only formula that links the load and the effort together. So to get the effort, we need to get the mechanical advantage first. Don't forget that, yeah? And to get the mechanical advantage, very easy. We can use the third formula, this formula here, which says that efficiency is equals to what? MA over VR times 100. So we can use that formula. So let's proceed. So we have our efficiency to be what? 75 is equal to, this guy, MA is what we are looking for, because we said that if we know the mechanical advantage, then we can get the effort. Yeah, so the first step we are taking is to getting the mechanical advantage first. Our velocity ratio was given as what? 4 times then 100. And then what do we have now? This can be rewritten as 75 100 MA over 4. So all I did there is to multiply MA with 100. So from here I can cross multiply now so that I have 100 MA, 75 times 4. Yeah, science students, if you multiply 75 with 4, you should get 300. Yes, you should get 300. And then dividing both sides by 100, our mechanical advantage is going to give us 3. Yes, so that is the first step, getting the mechanical advantage, which is 3. So the second step now is, now we know the MA now, we can proceed to calculating the what? The efforts. So therefore, MA, which is equal to 3, is equal to load over effort. And don't forget the load was given as 1,000 Newton divided by the effort applied. And from here, we can say that 3 is equal to 1,000 E, and this is 3E. When we cross multiply, we have 3E over 1,000 Newton, right? And when we divide both sides by what? By 3, we get our E to be, when you divide 1,000 by 3, we get our E to be 333.3 Newton. So let me run through that solution again. Yeah, so we were told from the question that the efficiency is 75%. We were given the load as 1,000 Newton. The effort was what we were told to look for. Our velocity ratio was given as 4. Yeah, and I said that before we can calculate the effort, we need to know the mechanical advantage. So that was why we used this formula first, that E is equal to MA over VR times 100. So efficiency was given as 75. So all I did here was to input all my variables into the formula. So that 75 is equal to MA over 4 times 100. Don't forget, velocity ratio is 4, E is 75. So I did the math. MA times 100 gave me 100 MA. 75 over 1 times 4, cross multiplied, got my mechanical advantage as 3. Yeah. So I now proceeded to using this formula now. That mechanical advantage is equal to load over effort. Don't forget, we already calculated our mechanical advantage. So that gives us 3 is equal to, our load was given as 1,000 divided by the efforts. So I just cross multiplied, and if you divide 1,000 with 3, you are going to get this. So as simple as that. So we are going to take more questions, but the issue with machines is just that everything applies, just all forms of machine revolves around this formula. So the only thing that changes is just the velocity ratio. The velocity ratio for a pulley is different from a velocity ratio of a wheel and axle. So what we want to look at now is the velocity ratio of different machines. So when we know how to calculate velocity ratio of different machines, then we can always use the same principle and the same formulas to get calculations on machines. So let's quickly take a look at that now. I'll be starting with the pulley. So the pulley are often used in construction sites to raise or lower heavy loads. I'm sure you've seen this before, where you have a big trailer or truck trying to lift some things from the ground to a particular height, or they are trying to lift it from a particular height down. So it's used in lots of industries and in construction sites. So how do we get the velocity ratio of such pulleys? If you look at the diagrams on the screen, you are going to see that for system A, we have just one pulley. So the velocity ratio for system A will be what? Will be 1. So the numbers of pulley gives us information about the velocity ratio. And for system B, we also have one pulley. That means the velocity ratio will be what? Will also be 1. For system C, we have 2 pulleys there, right? So velocity ratio is going to be what? Is going to be 2. And also for system D, while system E that has 3 pulleys is going to have what? 3 as its velocity ratio. So in conclusion, what we are just trying to say is just that the velocity ratio of the pulley system is generally equal to the numbers of what? Pulley. So if it has 5 pulleys, the velocity ratio will be what? To be 5. In lots of JAMB questions, you just see they draw the block and tackle system. A system of pulley is called a block and tackle. So they just draw a block and tackle. They draw 5 pulleys. They ask you, calculate the velocity ratio. You don't need to do any long maths. The velocity ratio of a machine like that is what? Is 5 because it has 5 pulleys. 5 pulleys. So that is for the pulley system. So let's look at the next one, which is the inclined plane. The velocity ratio of an inclined plane is given as 1 over sine theta. I'm sure we've seen a lot of this before. Like you see some, let's say you want to load drums of oil into a truck. You can see that in the image displayed on the screen. You have drums of oil being loaded to a truck. And you know it will be very, very tedious for wheel lifting because it's very heavy. So we can just get a what? An inclined plank. So all we just need to do is what? Is to roll. We just roll the drum into the what? Into the truck. So that is what we call the inclined plane. And then the velocity ratio of such machine is given as what? 1 over sine theta, where theta is the angle of inclination of the plane to the horizontal. Don't forget now that the ground is serving as the what? Is serving as the horizontal. So the velocity ratio is equal to what? To 1 over sine theta. That is for the inclined plane. So moving to the next machine now, the screw. We are familiar with screw very well. I'm sure at some point in time you've used the screw before, right? So how do we calculate the velocity ratio of the screw? So we use the formula 2 pi r over p, where the r is the length of the what? Of the handle, and then the p is the what? Is the pitch. The pitch is just the distance between the threads. The pitch is the distance between the threads. On the image on the screen, you can see the P there. The P there is the distance between successive threads, while R there is the what? Is the length of the tummy bar. Is the length of the tummy bar, which can be a spanner that is used in what? In tightening the what? In tightening the screw. So that is for a screw now. Yeah. While the next one, which is a wheel and axle. Yeah, I'm sure you've seen a lot of this before. We use it those days to, like, you can see that man over there trying to like wind some things, wind that wheel, you understand? So as it rotates the wheel, it also rotates the axle too. So it's just used to transmit power. So it's just a machine that transmits power from the wheel to the what? To the axle. So as the wheel is rotated, the axle also rotates. And then back then, they use it in wells to what? To draw water. Yeah. So we can, let's write that for wheel and axle. So velocity ratio of wheel and axle is given as radius of the wheel. So radius of wheel over radius of axle. So we'll be concentrating the machines we are looking in at, so the ones being tested on in examination bodies. So velocity ratio of wheel and axle is given as radius of wheel over radius of axle. The wheel is the bigger one, with the bigger radius, while the other one, the axle, is this one with the smaller radius. And then the last one is the gear wheels. You've seen this one before. Our bicycles have something like this. You have a big gear. You also have a small gear, right? And then the rotation of the small gear, it transmits power to the bigger gear, and it makes the other one to the bigger gear to rotate. and both of them are connected with a chain drive. Yeah, we have it in our bicycles. Just if the chain drive is removed from the bicycle, you're going to see that the bicycle won't move. You understand? Because the chain drive is the one that transmits power from the smaller gear to the bigger gear. Yeah, so most of these machines are used in our everyday lives. Yeah. So how do we calculate the velocity ratio of such machines now? All we need to do is to calculate the number of teeth of driven wheel over number of teeth. Let me rub this off. Number of teeth of driven wheel divided by number of teeth of driving wheel. Yeah, of driving wheel. Yeah, so we'll be stopping here, because those are all these are the machines being tested on in exams. So let's move on to questions on this now. So the first one is telling us that the efficiency of a machine is 60%. Find in joules the work done by a student using the machine to raise a load of 150 kg through a vertical distance of 2.5 meters. Very easy question. Let's just quickly take a look at it. Don't forget what we said, that the velocity ratio of the pulley is given by the numbers of pulley in the system, and then the velocity ratio of an inclined plane is given as 1 over sine theta. The velocity ratio of screw is given as 2 pi r over p. We are going to try all these formulas in question, so just stay tuned. The velocity ratio of wheel and axle is given as radius of the wheel over radius of the axle, and then the velocity ratio for a gear is given as the number of teeth of driven wheel divided by the number of teeth of driving wheel. So moving back to that question, we were told that the efficiency of a machine is 60%. Okay, so find in joules the work done by a student using the machine to raise a load of 150 kg through a vertical distance of 2.5 meters. Yeah, so our efficiency will be defined now by what? Work done by load over work done by students times 100. Don't forget that when I stated this formula, that we stated one formula that E is equal to what? To work output over work input times 100. And I told you that the output talks about the load, while the input, I'm sure you can remember, the output talks about the load, while the input talks about the what? Talks about the effort. So you can see that's what I'm doing here. So still work done, but this is work done by the load, and this is the work done by the students, which is as a form of what? Effort. And then the work done by the load will be given as the what? Times the load times distance moved by load, right? Remember that formula, that the work done by load is equal to load times distance moved by load. We used this formula, we applied it when we were deriving this formula here. We started from here, we got here. So from there now, we have that our E is equal to the load was given as 150 kg, so all we just need to do is multiply it with 10 times the distance moved by the load is what? Is 2.5 meters divided by what? Work done by students times 100, right? So how did I come across this? Very simple. Work done by load is equal to load times distance, right? And the load, which is the force, is a product of the what? Of the mass times the acceleration due to gravity. So in questions like this, you can always go from load to what? From mass to load. So if we are told that, let's say for example now I move a mass of what? 50 kg. That just tells me that the load is what? Is 500 Newton. Do you understand that? So to move from mass to force, all you just need to do is what? Multiply with 10. So if you are told that, if for example I move a mass of what? 40 kg now, so that means that my force or my effort is what? Is 400 Newton. So to go from mass to force, just multiply with what? With 10. So that was what I did here. So to convert the 150 kg to what? To Newton, I had to what? To multiply with 10. So that was how I got 150 times 10 times 2.5 divided by the effort of the students, which is the work done by the what? By the students times 100. Yeah. So that is how we go about it. And our effort, our efficiency was given as what? As 60. So 60 is equal to what? 150 times 10 times 2.5 divided by work done by students times 100. Yeah. So let's multiply all this together. If we multiply all that together, 10 times 2.5 would give us 25. And 25, okay, let's do it like this, that 60 times work done by students, if we cross multiply, we are going to have 60 times work done by students must give us 150 times 10 times 2.5 times what? Times 100. So from there now, I can use this 0 to cancel what? This 0. 2.5 times 10 is going to give me 25. So I have something like 6 times work done by students is equal to 150 times 25 times 10. And then 6 will go in 150 how many times? We go in 150 2. Remember 3, that will be 25 in 25 times. And then the work done by the students will be 25 times 25 times what? Times 10. So I'm just trying to like do everything without the use of a calculator. And then good luck to our JAM students. Yeah, JAM will be starting today, so good luck to you guys. Yeah. So work done by students will be equal to 25 times 25 times 10. So 25 times 25 gives us 625. And then work done by students, you can see, I actually did this without the calculator. 6,250 Newton. Yes, that is going to give us 6,250 Newton. So let me run through that solution again so as you get it. So we started that with efficiency is equal to work done by load over work done by students times 100, right? So I said the work done by load is a product of the mass of the load. We multiply the mass by 10 to get the load itself. Then we multiply by what? By 2.5, which is the distance moved by the what? By the load, all divided by the work done by the student times 100. Yeah, I know what I wrote say looks like cumbersome, but everything here, all you just need to do is what? Multiply all this together, divide by 60, and you get this answer. As simple as that, right? Just multiply everything here together, divide it by 60, and you still get this answer. As simple as that. Yeah. So I was just trying to like take it step after step. You understand? That is why we have all this pen down on the board. So let's move to the next question now. So the next question says that a machine has a velocity ratio of 5 and is 80% efficient. Yes. So what efforts will be needed to lift a load of 200 Newton with the aid of this machine? Yeah, so let's solve that. But before we do that, I would like to say something that all machines don't work at 100, they are not 100% efficient. And I'm sure you know the answer to that. The reason is just due to friction. Yeah, I've seen a few questions like that in your exams. They ask you that why are machines not 100% efficient? So the reason for that is just that we need work to overcome friction, right? And if friction needs to be overcome, that means we can't get 100% again. You get what I'm trying to say? Yeah. So the answer to that is just that work is done to overcome friction. So you can't get any perfect machine anywhere, right? So probably 90-something%, but it's hard to get 100%. So let's move to that question. So a machine has a velocity ratio of 5 and is 80% efficient. I'm sorry if I'm too fast. I'll go slowly. A machine has a velocity ratio of 5 and is 80% efficient. So let me write the parameters on the board. It has a velocity ratio of 5, right? And it has an efficiency of 80. It has a velocity ratio of 5, efficiency of 80. So what effort will be needed to lift a load of 200 Newton using this machine? So we want to lift a load of 200 Newton. So the question says we should calculate the effort needed. Don't forget, we answered a question similar to this the other time. I told you that before we can get the effort, we need to calculate the mechanical advantage of the system. Yes. So before we can get the effort, we need to calculate the mechanical advantage of the system. And how do we calculate the mechanical advantage of the system? We simply use the formula that efficiency is equal to MA over VR times 100, right? This formula here, efficiency is equals to MA over VR times 100. So our efficiency is what? Is 80, is equal to, MA is what we are looking for, right? Divided by velocity ratio is what? Is 5 by 100. So let me take that again. We were given velocity ratio as 5. We were given the efficiency as 80. We were given the load as 200 Newton. The question says we should calculate the effort. Fine. How do we do this? We need the mechanical advantage. Don't forget that the only formula on the screen linking load and effort together is what? Is mechanical advantage. So that means we need to calculate the mechanical advantage before we can get close to calculating the effort. So that is why I started with this formula, so I can get my MA first. So all I did from here is to input my variables, right? So my efficiency was given as 80, and my velocity ratio was given as what? As 5, right? So if I do the maths, I'm going to have something like 80 times 5 is equal to 100 MA. How did I get that? I cross-multiplied here. So I have 80 multiplied with 5 is equal to 100 times what? Times MA. And if I divide both sides by what? And that is going to give me what? 8 times 5 is going to give us 400, right? So dividing both sides by 100, my MA is going to be equal to what? 4. Yeah. And if our MA is equal to 4, we can proceed now to calculate our effort. So don't forget that MA is equal to load over effort, right? So that means 4 is equal to 200 Newton divided by the what? By effort. So without calculating, I'm sure you all know that our effort will be what? 50 Newton. But let's still calculate it to see what happens. Permit me to rub up this place, please. So we have MA is equal to what? Please always start every physics question with what? With the formula. You writing this formula alone is what? Is like at least 1 mark. You get that? So always start every physics question with every physics calculation with the formula. So from here, our MA is what? Is 4 is equal to, we have a load of 200 Newton, and let's represent our effort as E. So if we cross multiply here, we have 4E is equal to 200 Newton. Dividing both sides by 4, our E is equal to 50 Newton. Very simple. So let me go over it once more. Velocity ratio given as 5, efficiency given as 80, load given as 200 Newton, effort we don't know, we were told to find. So we started with efficiency is equals to MA over VR times 100. 80, which is the efficiency, is equal to, all I did was just to input my variables, and then we got our MA as 4. So using this formula, MA is equals to load over effort. Putting in your variables, you get your E as what? 50 Newton. Very simple. So let's move to the next question. I'm sure you are jotting all these questions down. So the next question now. A block and tackle system has a pulley consisting of, a system consisting of 4 pulleys. Yeah, so before we start that question, I want someone to tell me what will be the velocity ratio of that machine. We are told that a block and tackle system of a pulley consisting of 4 pulleys. Yeah, so what will be the velocity ratio for that machine? If it has 4 pulleys, then what will be the velocity ratio for such machine? Please, I need a response. It has a system of 4 pulleys. Okay, so that means velocity ratio is equal to 4. I have my answer already. Velocity ratio is equal to 4. Consisting of 4 pulleys is used to raise a load of 500 Newton. Used to raise a load of 500 Newton, right? Okay, through a height of 20 meters. So distance moved by load is 20 meters. Is equal to 20 meters. So if the work done against friction in the pulley is equivalent to 800 joules. So work done against friction now is equal to 800 joules. Then the question says we should calculate first the what? The total work done by the what? Effort. So the work done by the effort, will be equal to the work done lifting the load times work done against friction. So work done in lifting load plus work done against friction. So that is going to give us the work done in lifting the load will be what? Will be the load. That will be 500 Newton times 20, right? Yes, because we said that work done is equal to force times distance. So that's going to give us what? 500 times 20 plus what? Plus 800 joules. Because the work done against friction was given as 800 joules. And that gives us 10,000 plus 800 joules. And that is going to give us 10,800 joules. So the work done by the effort is equal to 10,800 joules. And then don't forget that the work done in lifting the load is what? 500 times 20, which is what? 10,000. So the next question tells us to calculate the efficiency of the machine. So how do we calculate that? Okay. So the second one, the efficiency of the machine now is equal to the work done by load over work done by effort times 100, right? Okay, so the efficiency, E, will be equal to work done by load is what? Don't forget 10,000, right? Because we said that the work done lifting the load is the product of the load times the distance moved by the load. So that will be 10,000 divided by 10,800 because the work done by the effort is equal to, we calculated that in the first question. So all we need to do is multiply this with 100. And when we do this, we are going to get a value of 92.6%. Yeah. So you can just put this in your calculators. You get 92.6%. And then the last question is telling us to calculate the The last question says you calculate the effort applied. But before we can calculate the effort applied, we need to calculate the what? The mechanical advantage of the system. So calculating the mechanical advantage of that system, we use efficiency is equal to MA over VR times 100. And then our efficiency from the last question was 92.6 is equal to MA. Our VR was given as 4 because the system has 4 pulleys times 100. So our MA would be equal to what? If we cross multiply 92.6 times 4 over 100. And our MA is given as 992.6. It's given as 992.6, and therefore our effort okay, so don't forget that MA is equal to load over effort. So if we apply this, we were told that the load is 500 Newton. So our effort is going to be 500 times 100 divided by 4 times 92.6. Four times 92.6. Okay. Okay, so this is going to give me E as 135 Newton. Yeah, E as 135 Newton. So let's take a look at it again. So let's leave this as load over effort first. So that let me just quickly run through this again. So this will be 92.6. Let me just do it straight. L over what? 4E times what? Times 100. Okay, so our load was given as what? As 500. So that is 500 over 4E times 100, right? So if I cross multiply here, I have 92.6 times 4E is equal to 50,000. And if I divide both sides by what? By 92.6 times 4, I'm going to get my E as what? As 135 Newton. So I think it's simpler that way. Yeah, it's very easy that way. So I just substituted my MA as load over effort, and then I did the math and I got my E as 135 Newton. Yeah. So okay, Onyeka said he doesn't understand the previous step. So the first thing I did, the first answer was I said the total work done is equal to work done by load plus work done by friction, and the work done by load was calculated as the product of load times distance moved by load, which was given as 10,000. I added that with the what? With the work done by against friction, and that gave us 10,800 joules. That's the work done. That's the work done by the efforts, right? So the second question says you calculate the efficiency. So the efficiency is equals to work done by load over work done by efforts times 100. So we did that and we got the efficiency as 92.6. So in the third one, we said that efficiency is equals to MA over VR times 100. So our efficiency is given as 92.6. Our MA is given as load over effort divided by velocity ratio, which is 4 times 100. So if we do this math, we have that 92.6 is equal to L over 4E, and then we got E as 135 Newton. So we are going to be stopping here. So as I said earlier that our session break now. So our session break is going to. Okay, so we are going to go on a break now, right? We are going to go on a break now. So when we come back, we are going to move on from here. Thank you. Okay, welcome back. Yeah, welcome back from that break. So before we start the assessment questions, let's just quickly take a look at everything we've talked about. So we started with the definition of machines as a device that makes work easy. Then we mentioned examples of machine: the pulley, the lever, and wheel and axle, screw are all forms of machines. Then we said a machine can be used, is efficient, can be used, we use a small effort to overcome a big load, and then it is versatile, and we mentioned some other uses of machines too. Then we proceeded to some terms used in machines. We said the MA can be calculated as load over effort. The velocity ratio can be calculated as distance moved by effort over distance moved by load. And we said that the velocity ratio for different machines are different, right? Yeah, and we said the efficiency is equal to MA over VR times 100 is a formula that connects the three parameters together: 1, 2, 3, mechanical advantage, velocity ratio, and that. Yeah. So let's now proceed to our questions now. Yeah, so the first question here is saying that a machine with a velocity ratio of 30 moves a load of 3,000 Newton when an effort of 200 Newton is applied. The efficiency of the machine is, okay? So I need your answers to that question. So I need your answers to that question. So I'm still waiting. So Habe, you asked if you can just put in all the parameters. Yes, you can see that last question, that was what I did. I just slot in all my parameters and I got my effort. So you can do that. So just calculating the MA makes everything look easier. So that was why I went like that. But you can also substitute all your parameters inside. So do we have answers for our first assessment question? So someone said the efficiency is 50. Okay, Emeka, yeah, 50%. Thank you for those responses. 15%, that's a bit low for a machine. Okay, while your answers coming, let's just quickly solve to see who got it correct. So we were told that we were told to calculate the efficiency of the machine. So efficiency is equal to MA over VR times 100, right? And our MA is equal to what? Load over effort. The load was given as 3,000 Newton, and an effort of 200 was applied. So if we do that, we are going to get our MA to be 15. Yeah, to be 15. Yeah. So from there, don't forget, you don't stop there. We don't stop there. The efficiency is now equal to what? 15, which is MA over velocity ratio of the machine was given as what? As 30 times 100. I'm sure those of you that got 15, you stop here. You don't stop here. So if you do that, 15 year 1, year 2, 2 in 100 is what? Is 50. So our efficiency will be equal to what? To 50%. So the correct answer to that question is what? Is 50%. Yeah. So Benedicta, Emeka, Onyeka, Okpeyemi, and then Oreolua, thank you very much. You corrected yourself. Yes, it's 50% and not 15. So thank you very much. So let's move to the next question now. The velocity ratio of an inclined plane whose angle of inclination is theta is given as, I need the expression for the velocity ratio of an inclined plane whose angle of inclination is equal to what? Theta. Okay, so I need your response. The velocity ratio of an inclined plane whose angle of inclination is theta is given as. Thank you for those response. So the velocity ratio of an inclined plane is simply put as what? As 1 over sine theta. All the answers we got are all correct. Thank you very much. So for those of you just joining us, every Saturday like this, we'll spend 1 hour to learn. So we have science subject, maths, English, physics, chemistry, and biology. So 11 a.m. is next week Saturday, 11 a.m. is another time to be with us. So please don't forget to always join us at 11 a.m. And you can also watch our videos, our past videos. Just log on to learnatom.ng. So you can watch our past videos there, yes. And even this video, if you were not able to join us today, just log on to learnatom.ng. Yeah, you would also have access to the video.